Number one, we need to write this as a fraction and decide if it's rational or irrational. Well, I can start you off. Irrational means it never ends, which is true with this case, but it also means it never repeats. This little sign means this is 0.6666666. That doesn't work. That's never going to repeat this. So this is rational, which means we can write it as a fraction. Many of us probably at this point have seen 0.6666666 enough times and have just remembered that 0.333333333 is 1/3. And if you double that, 0.366666 is going to be 2/3. Maybe you do remember that. Another thing we could do, though, is we can look at this. This is in the 10th place. So we can write 6 out of 10, but it's not actually 6 in the 10th place because it's 66 in the hundredths place. It's 666 in the thousandths place. So what we'll do is we'll take this 10. The trick here is to just subtract 1, 6/9, which does reduce to 2/3 if you divide by 3, divide by 3. So it's 2/3. Number 2, you need to multiply -5 by itself 3 times. -5 times -5 times -5. Well, negative and a negative, those cancel off. Those will be positive, but we still have one more negative. So make sure your product is negative. Do 5 times 5 times 5. Number 3, we have 2 perfect squares. This is 11 times 11, so this is positive and negative 11. This is positive and negative 9. This one is not a perfect square. So you're going to give me positive and negative approximately blah, 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 blah. You can round it to like just the tenths place. And then put it on a number line. You're going to have 0 in the middle. You're going to have a positive 9, negative 9, positive 11, negative 11, and figure out where that other one's going to go. Number 4. By the way, on number 3, if you forgot why I'm having positive and negative, well, 9 times 9 is 81, but also negative 9 times negative 9 is 81, because 2 negatives, like I said up here, cancel each other off. So your answers for these got to be positive and negative. Number 4, we're going to use what's called the negative exponent rule. 2 to the negative 4th is the same thing as 1 over 2 to the 4th. So you just flip it, put it on the denominator of a fraction. Instead of this over 1, you flip it over. You use the inverse of it because this is the inverse of an exponent. So we're going to say 2 to the 4th on the denominator. Well, this will be 1 over, tell me what 2 times 2 times 2 times 2 is on the bottom here in the denominator. Number 5, we've got a scientific notation division problem. And this problem is kind of crazy. I put it up here so we can have a little extra room. However, it's not as crazy as it looks. We're going to break this into 2 parts. We're going to divide this section. Well, negative 8.4 divided by 2.1, that's actually going to give us a good number because 2.1 times 4, well, 2 times 4 is 8. 1 times 4 is 4. So that's our good number. So our answer here, this is just going to be -4. Now, 10 to the 15th over 10 to the 3rd, so we'll have 1, 15 zeros, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, divided by a 1 with 3 zeros. Well, if you see this is a fraction. We can reduce this fraction. We can reduce this. We can divide by 10. We can divide by 10, and we can divide by 10. So we end up with 10 to the how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 10 to the 12th. So when we're dividing with scientific notation, it's actually not that bad. We have this extremely big negative number. We're going to divide by 2,100. But in this case, we can break it into these 2 pieces. We can do just the first part and get that. And we can do this 15 minus 3. We get 10 to the 12th. And we've got it. So it's -4 times 10 to the 12th.